So, welcome everyone to Developers Meeting on June 5th, 2022. We were just talking about the balloon starts, and Kristen is now going to show us the payload that went up into very low Earth orbit, let's say 35,000 kilometers up. Go ahead, Christian.
On the outside of the payload box, Tobias mounted this badge. We chose the one with the darker orange one that looks a little bit like gold, and it was put on. I think it's glued on it now, and in the box we put the other two badges. Then we put and buddy of mine a business card from Optic, because Optic will provide us with optics and cameras and stuff. And then we have got this little nice unicorn. You see the unicorn here? Yeah, this is the unicorn, because then we can say, since we got it into our hands back, we caught a unicorn. Yes, we had these little stickers here. They were put. Okay, they're both put inside, so it shows that UAP Society and Sky 360s is a joint venture. Then here's the USB stick. On it are 379 folders with the NFTs on it. It's about 24 gigabytes right now, and this badge mounted outside was illuminated by a small improvised lamp. Let's say it. It is just okay. I'm going to put it together. It's 2 3-volt batteries and a small LED, which is very, very bright. And this illuminated the badge during its flight up, so the camera could pick it up. And I think the video was very nice, and this improvised lamp worked pretty well. And it still does. So yeah, I think this is what I can say about the launch, and yeah, I'm looking forward to the next one.
We can say we learned an easy lesson, Christian. We learned how to mount the patch, the logo.
Yeah.
Not upside down. And we also learned to enlight it, right?
Yes. I didn't put the payload together myself. This was Toby and his buddy Marcel, I think it is, was doing. And yeah, and one thing we built up for the event, I did that with my father. We now have got a light box for night launches. It looks like this. And on each side of that, okay, this is top down. On the we can put anything that is see-through on it, and we can illuminate it. I'm not doing it right now, but yeah, this is a night box that is rainproofed now, because we had some bad weather at the end of the session. And yes, and if we are somewhere and we can illuminate it and put stickers, logos, and anything like that on it, we can go to further conferences or whatever. So yes, I think we're good to go for the next session.
All right. So, okay, let's go into it. We have today here some developers, Rebecca, Jannik, and Christian, and Bojan, and Brad. And let's update ourselves about what happened in the last weeks, what was developed, what is the status, what is the current status. I think we start with Rebecca, if you allow me to. As far as you know, Rebecca is in the user interface, and I created some user interface visuals. Rebecca, one question to you about this, the user interface. You asked me about icons, and I asked back about the size of icons and how you want to use them. My question again, do you want one template, now how you say, one sheet with all the icons on it, or do you want each icon separated?
Well, I thought I would, well, it actually doesn't matter. Can you hear me okay?
Yeah, absolutely.
Okay. Yeah, it doesn't actually matter. I want to do the styling at the end, but I prefer them as individual icons, but you can do a whole sprite sheet, and I can use the sprite sheet instead. And if I want to, I can cut that up, or I can just keep everything on one sheet. So it doesn't really matter. It's up to you, whatever's simplest for you.
I have to extract them anyway, so for me it doesn't make any difference. So I will produce them individually. So in their native resolution of 32 and 48 pixels, I think we use right now. Kind of.
Okay, thanks.
Okay. I will do that. Yeah. Okay. Lionel is not here. I wanted to talk with about what Lionel did, what he presented 2 weeks ago. I wanted to know whether there's a new update on it, because it's about overlays over the video of the fisheye video, and what was raised in the last couple of days was additional data sources. Jannik is on those data sources, and one of these data sources is ADSB data. So the idea is, of course, to make it easy for anyone without buying equipment to use ADSB service like OpenSkies, for example, and then retrieve the data via an interface that Jannik is going to create. But my point here is that this is certainly not a 100% data set. And I think it makes much more sense if this data set that is from a server where registered planes and aviation vehicles are registered, that it's a good start for anyone to see what happens in their environment. But for someone who wants to have the additional 20%, let's say the military planes, the not registered planes, to see whether something that is flying is already a registered one, or transmit the signal via the transponder. So in order to make the long story short, there's equipment that's called Noeelec, and it's just $70. You get it on Amazon, and it has 2 cameras, even a Y-splitter, and you can do very easily an ADSB receiver in your station, which delivers a 100% accuracy of all the transponders that are on. Did I make myself understandable what I mean?
I think I've got some equipment to show. I've got the Noeelec SDR thing, a camera, and the filter attached to it. Just takes me, let's say, a minute, then I can show you.
Christian, it is about equipment that we can promote to people in the future. That goes on our current list of hardware. It's not about how ADSB works or what equipment someone has.
No, it's just to show how the equipment looks like, so the people get more the idea of what you can do with it, because you can show it.
It's basically 1 to 2 to up to 4 or even 5 antennas. They're short black antennas, and with antenna cable they plug into a receiver, and then you have something that can decode and sample and blah blah blah. Noeelec has a nice equipment there. It's easy to set up, and there is Aussie Joe, and I name him with his tag that he's running here on Discord. He is an electrical engineer, and he is now going into the ADSB data. He bought that equipment from Noeelec, and I want to show you his first results. So hold on a sec, I have to share my screen. So is my screen shared?
Yeah, I can see it.
All right. So within the day, he brought that up. So it was very quickly and easily done by him. He is an engineer that he's, let's say, in our age right now, but in his earlier years, he was very much in ham radio and SDR, passive radar, and so forth. And he's now bringing back this equipment and now helping us sorting out the right hardware for the task that we task him. So for now, for the start, I'd say, because the ADSB topic was raised, and I stop sharing now. Stop. Because the topic was raised, that we have external sources, but for that kind of ADSB, I would say we also have an internal source. And yeah, that sources, no matter where they are coming from, have to be projected onto the Fisheye stream, the video material is coming from. So what Jannik already did is, but better Jannik, you can tell by yourself if you can.
Yes, I can give a quick overlook because I still have 7 minutes to do that.
Perfect.
Good timing. So maybe I can also just quickly share my screen. And actually, I posted almost everything on Discord already, but so maybe I share my whole screen, I guess. So this is something I just pulled for Berlin, actually. So do you see my screen now?
Yep.
Yep.
Okay, so this is my code basically, and this is what you can see for Berlin from 10 minutes ago. The planes that were recorded there with the Open Sky API, and I think this could be a good way to display the aircrafts in the surroundings of the station in the fisheye view. But what you also can see here currently is when you have two aircrafts which are close by, there's a slight problem with the text boxes, so I have to solve that. And my idea actually was now that maybe we just have these little icons for the aircraft in this view, and we have the aircraft with text boxes actually in the map view. So we have two different views. We see the aircraft in both, in the map view and in the fisheye view. And in the fisheye view, we just see the aircraft. I think that's much better and easier. And you can see different info. Yeah.
Maybe a suggestion in that view to it may be good if you hover the mouse pointer over it, then the text will appear. Is that a good idea?
Yeah.
Yes, I also thought about that, but that now brings us to another thing that I think we have to discuss at some point, which is has to do with Django. And a long time I thought, because I'm not in web development and so on, I didn't know too much about Django, but I always thought you can use Python code to display to use for the front end. And this is actually not really the case. So in Django, you have a Python backend, but as I understand, you have a more like a JavaScript and HTML, CSS front end. And it's not really designed to use Python code to display anything, and especially not anything that is interactive.
You have to use a viewing modal for that and blend in the viewing modal.
Okay. Okay, so
I just
then
wanna
maybe
say-
Beeks can say something about it.
Yeah. I
Yeah.
just want to say, can you hear me okay?
Yes.
Okay, I just wanted to say that's not going to be a problem because I'll just use your code, and if I need to modify anything on the back end, I can do that. But I'm going to use your code, and then I'm going to use the front end if needed. So it's not going to be an issue, in other words.
Okay.
I hear a lot of noise, so I'm distracted. But it's not going to be an issue. It's not even it's not even a problem for me.
Okay, that sounds good. So that was basically all I did in the last day. So I can, if you have any questions, I have another 3 minutes that we can discuss what I did. So
Okay.
Yeah, let's say, first thing, thank you for the good work. And yeah, that looks promising.
okay, yeah, welcome.
One thing that we have to solve is projection. So, Jannik, we were talking about this, and you were using a simple hemispheric projection because a fisheye optic is stretched from the center to the sides. The position of the elements have to be corrected, right?
Yes, so from my understanding, it is what I use here is suitable for the so-called equidistant fisheye system. So that is using like a linear projection factor, let's say. And this is so what I learned now is that these fisheye systems, that these equidistant fisheye systems, that are the most, these are the most popular version, let's say, but they are not usually, so the real camera systems are not ideally equidistant, so they deviate to some degree from this ideal, and that is something that needs to be corrected, probably to align these little aircraft symbols with the real aircraft, how they appear on the fisheye view. So on the real fisheye view, so the real aircraft might be positioned here in the real view, and the symbol for now would be here or something like that. That there's probably a small error, especially around the edges, as far as I understand. More to the middle, it's probably not much of a difference, but the more you get to the edges, the more deviation you probably see. That's how I understand it currently.
Yeah, it goes up to 30 degrees above the horizon. So there are distortions coming from the fisheye lenses that go up to 30 degrees above the horizon.
Hey, Christian,
Okay,
is there a polynomial for, let's say, for a fisheye optic? Does the manufacturer of a fisheye optic give us the polynomial function of the curvature?
I have to ask Pergear about it, but as I know, for now, Pergear doesn't provide it.
Okay. Can we?
So I have to talk to them and maybe ask if they can give it to us, and then we can correct it.
Okay, in case we do not get it, we could work that out for ourselves for a particular fisheye.
Yes.
Yeah, I have to move on.
Yeah.
See you guys.
Okay.
Bye-bye.
See you, Jannik. Bye bye.
Thanks.
So, hold on. Snake, I have to mute you because your microphone is getting wind noises. Okay. So, hi Lionel. Good to see you again.
Hi. Hi, how do you do?
How are you doing? So, You presented us last 2 weeks before some
Hey.
updates on your kinematics classification. Any update up to now?
Yeah. What I'm trying to do is very small increment on the steps. So instead of trying second order polynomial and then third order polynomial, I try to do 1.5, 1.6, 1.7,
Yeah.
and I see some very wild movement in the shape of the
The
curve.
cluster. Okay.
So I'm hoping to end up with something good there. I have some good hopes.
Mhm.
And just the last week, I was mostly working on having the display better. So just focusing on one track and have it displayed right with the parameters and the dots, and just to display correctly, to have a better understanding of what's going on.
Mhm.
But so that's the approach I was taking last week. I'm away and I have guests today, so I won't be able to stay much longer.
Mhm.
But okay, so that's what I can tell you. That I've been yeah, had quite a lot of work, but so I think that I'm on the right track. I think I'm gonna have something good, but it takes some time, which I didn't have very much in the last
All right. No problem.
weeks. And for me, it's going to be June on June 30. I will have plenty of time because my assignment is ending on this date, and I'm not looking for another one after that to be able to complete the Sky 360 project
Perfect.
starting June 30.
Perfect. Good to hear, Lionel. Thank you. Just
Yeah.
for the ones who are not familiar what Lionel does, to give you an idea. So when the fisheye material is streamed into the system, the first level of detection is a motion detector, a very basic motion detector that just reacts on changes in the sky, trying to avoid clouds and finding the signal in the noise. So, because it's a video, we've got a timely frame mass coming in, and by each frame being analyzed, we see where, let's say, a moving object is in the sky in this view. And by this, we can connect all those dots and create a track. So this track is the path that is seen by the fisheye camera that the object took in the sky above it. From that path, we can derive things because we know that a plane behaves different in the sky than a bird, or an insect, or a drone, or a balloon. And because we know that, we can classify that. So we only have to know, because it should be an automatic system, what that classification is. And this is Lionel's task. Lionel tries to find out what polynomial functions do best fit curves that belong to the same behavior cluster, let's say. So if we can melt it down to say birds have this cluster of behavior, planes have this cluster of behavior, then the software can very easily give probability factors for each track.
Yeah.
But at that time,
And
it is not about, and this is very important to know, it's not about 100% detection. It's only giving the first grade of detection, a probability, a first probability. Because the motion detector per se does not tell this. The motion detector only says there's an event, there's no event. But then the kinematics classification is the first level to tell us, let's say with a probability of 60%, it's a bird. because there is on the back side, there's the master control program, which we call master control program, controlling all sensors and also getting those events in. So getting the events from various sensors, but also from the fisheye on various levels. So the first level is the motion detection per se, where it says there is something moving above me. Because there are times where nothing is moving, of course. But in most times, there are multiple events taking place at the same time. So it's important for the master control program to find out which is an important event to track, which is to point a pan-tilt zoom camera towards it to get a close-up, to get a more detailed image, so that the AI, the neural network classifier that goes on image recognition, then gets a very high resolution image, which is more or less that what we all want to see at the end. So this whole approach is a multi-level approach, and Lionel is first line of defense here. Okay, we heard Christian, Beeks, and Lionel. Is there anything else we want to recap from the last week? Brett, anything from your side?
Bojan is trying to ask a question.
Oh, Bojan, go ahead, sorry. Wait a sec, Bojan, you're muted. I unmute you. Go
No,
ahead.
you.
It's on your end, Richard.
No, okay. Sorry.
Try.
You might have to restart.
You're just not hearing Bojan.
Okay. So
He don't want to hear
no, I
me.
hear
I
him.
know.
I hear him.
That's okay.
Okay.
Hey, look! You said the airplanes, army, the airplanes is not registered officially. How can we know?
So in the U.S. at least, military aircraft, unless they're given some sort of special exemption, which is kind of a rare thing, they do show up on ADS-B. And I'm actually comparing OpenSky to ADS-B Exchange right now, and it's kind of hit or miss, actually. There's some military stuff showing up on both, and then other times only ADS-B Exchange has the C-130 that just flew over. So I don't know what the discriminator is there, and why they show up sometimes and not others.
My point is the civil airport or whatever need to be notified for any army flight, right?
Yeah, at least in the U.S.
Yeah.
Same in Europe. So yes, Bojan, per se, every plane that has a registered flight path has to turn on its transponder. But
so how can we know? How can we know?
Yeah, that's a good point. How can we know? So if you see something flying overhead, and we are here in Austria, and we have a lot of NATO flyovers, and we know that only half of them are registered. So we see a lot of black flyovers.
I mean, officially registered.
Yeah, officially. So they're, let's say, a military plane from the NATO that goes from Germany to Italy, and Austria is not in the NATO. Do they think they care? They just fly over, because the flyover takes them 5 minutes. We cannot even bother them to not do it. We cannot even prevent them. So what I'm going to say is there's a lot of military air traffic that is registered, of course, with the military probably, but it is not registered on those servers that are publicly available.
Must be somehow registered, because we will be collision with civil airplanes.
You still have air traffic control, and you have radar on the planes themselves. You don't have to rely on ADS-B. It's actually a new system.
Okay.
So it's to help keep track of planes globally. Like after the Malaysian Airlines that crashed in the ocean and disappeared, it kind of became an initiative. It's gotten pretty popular. Now it's
my
standard.
basic question must be registered. Every flight must be registered.
Yeah,
right?
Of course, military flights are registered too. So normally, if a NATO plane goes over Austria, they're registered with the Austria control. But
excluding Austria. Nobody cares about Austria in Europe.
True, but anyways, although it is registered, it does not say that the transponder is on, because the pilot can just switch it on and off, the transponder. It's in his power to do so. And what those military planes, the flyovers especially, do when they have contact with the traffic control, when they lock in so that they're in their airspace, they turn it on shortly for some seconds so that the radar operator knows who it is, and then they turn it off again.
Oh, okay.
And all this back and forth, and all this not having 100% safety. No, it's the wrong word. How do you say this in English? Not to be 100% sure whether the data that is on those servers is accurate, because we cannot trust that it is not. We cannot trust it to be 100% accurate. That's why it's at least my proposal to use Noeelec devices and do ADSB receiving ourselves. A receiver costs $70.
It looks like this one here.
Yep.
This is one of the receivers for Noeelec. This is the mounted antenna with a filter for it, and you can just put it on a tripod like this. I'm doing here, and just put it to your laptop. The software you can use, I think it's GSDR or something like that. GPX is working fine too. It's freeware, and you can track frequencies from 1 hertz up to 2.4 gigahertz. Above that, you need a different antenna.
Mm-hmm.
And below that, of course, yes, this antenna goes for the 1090 megahertz, especially. And if you want to pick up, let's say, brain waves like that, your antenna has to be at least 150,000 kilometers wide. It's lambda half.
Can you share the link?
So the good thing is on. Pardon me? What did you say, Bojan?
Can you share the link?
Yeah, you can you can get it with Amazon.
Okay.
Yeah.
I will share the link, Bojan, because we're talking about a certain product from Noeelec. And the good thing is, in this product, it has a Y-split, which means you can take 2 different antennas. We can use a simple device for $70 for 2 modes at the same time.
No, I can build an antenna myself. I mean, it's no big deal.
If you want to, of course, you can. But that's why we want to test the Noeelec device for these 2 purposes. So one is the ADSB, and the second one is, let's say, it's my proposal, and I want to hear your thoughts about it. I'm sure you all saw Skinwalker Ranch, the last episodes, right? When Travis Taylor mentioned this 1.6 gigahertz signal coming in, and what baffles me most is that he has a feedback loop from this passive from the spectrum.
That was strange.
Yeah.
That actually means that there is a hearing device somewhere, and it is not inside the room, it's also outside the room. Because it has to transfer an analog audio into a digital one, transmit it up to the air so that it is reflected back to the spectrum analyzer and then played back.
In real time.
In real time, with a very short delay in the echo.
It's underground.
It's in the ground.
Yeah, that was my first suggestion too. But if we consider that the whole basin is like some kind of dish, like let's say the dish at Arecibo, then yeah, it has to be underground. The facility that collects the data, that manipulates it and sends it back.
In a way so that it's in a self loop that we watching Skinwalker Ranch see that they are talking in echo. I mean, I was so baffled at that moment. I thought, what? Is no one else crying here? I mean,
You have to demodulate the signal in order to be able to do that, though. That's what doesn't make sense. Right? You can receive any signal, you can monitor any signal, but you have to demod it in order to hear it, to see what's in that signal.
right.
So
Yeah.
what would be doing that? They're not doing it, so it's like something that's doing it for them. So it doesn't make any sense how that's possible.
So you say that Travis Taylor turned the spectrum analyzer on only visually, but not audially. But the audio is coming from the spectrum analyzer, didn't it?
Agreed. But what I'm saying is that you can see the signal. The spectrum analyzer is meant to see the signal, but it's only meant to decode what it, demodulate that signal and tell you what's in the signal. And
actually, what kind of modulation is?
Exactly.
Amplitude, frequency, phase modulation. This is very important.
So this
Exactly.
the spectrum analyzer had to do that in advance to be able to process, because it's a digital signal probably.
It's
Yes.
not possible.
This is not a 1.6 gigahertz itself. It is modulated.
Yeah.
So you have some not only signal 1.6 gigahertz, but what kind of modulation is.
Yeah.
You mean an
So
analog
modulation actually has data.
Yeah.
Okay.
So those of us who aren't fans of the show, how does this relate to our mission?
How does this relate to our mission is a good question. Good question.
How do you
it's a hint of what we can think of.
I think
May I-
the link is, Brad, that it's not the only hint. The second hint
May I
is
speak?
Chinzagala.
Yes. The gamma readings, right?
May I speak?
Because they have the same spikes. They are above 5 times above the ambient. And certain people have issues.
John wants to talk.
John?
Yeah.
Hey, you know what happened with me when I was in Kansas and Missouri? I was hearing the sounds, two different sounds. Since I'm a musician, it was C sharp, very low frequency, like a woo all the time. And and then since I was moving here in Florida, I'm not hearing this sound anymore. So I was reading about that on people hearing the low frequency sound, not through because lower frequency you feel through the body, not through the ears. And I was reading, and they said something in the brain, blah blah blah, and one guy told me that this is from electrical line and stuff like that, but I'm not hearing this anymore here. I don't know. I mean, this is just
In the rain, high lines do have that low hum. Yeah.
Yeah, and this is the strict frequency, and I was tracing on a keyboard on a synthesizer like a C sharp and 1 octave, and very low, like around 200 something hertz. But I'm not hearing anymore. It didn't make me dizzy, didn't make me sick. You just hearing these sounds.
Can you compare the sound to anything that you know?
No. This is I mean little lower, and this is it.
Okay.
And I was hearing this all the time, and I was asking people around. They thought I'm crazy. I'm not crazy. I'm hearing this, and then I moved to Florida. I'm not hearing this anymore. So I don't know.
Because you don't have Slivovitz anymore.
No. It's not connected with alcohol and shit like that. But
Yeah, it was a joke. I know, Bojan.
Yeah, just saying, could be something. So what's happened? Even, for example, old tube guitar amps. When you have hum, low frequency hum, this doesn't mean you have problem with the ground. You have problem with RF, high frequencies. I mean, difficult to explain. But when you have low frequency hum in a tube amps, old tube amps, more likely you have problem because with high frequency interference.
Because it's resonates. Yeah, it resonates down into the frequency. Yeah.
Yeah, and then because tube getting overheated, and you looking on an audio spectrum, but it's not. It is RF spectrum. But since we cannot hear the radio frequencies. Somehow in this electronic equipment you have low hum from the high frequencies. So you know this is so for me this 1.6 gigahertz tell me nothing. You know, tell me nothing. What kind of spike is that? I mean, I don't know.
The L band. It's the satellite communication band.
Yeah.
But why is it only reacting on certain people? You saw it in Skinwalker Ranch. One were affected, the others not.
That's what I'm telling you. I was hearing this sound. Maybe this sound, my brain was projecting some kind of high frequency on a low. I don't know. So some people can hear, some people cannot.
Yeah, but devices are listening here, so it is registered. Yeah. Hey, John, you wanted to say something, right?
Yeah, if you guys don't mind.
Yeah, go ahead.
I mean, I made the last meeting, and I appreciate you guys let me, speak and whatever, and I appreciate your work, all of you. You guys were talking about Skinwalker, and I think that's a localized phenomenon out there. A lot of the stuff that goes on at Skinwalker is going to be localized to the area, in my opinion, because of the basin shape, because of the underground movement of things, whatever that is. They got a lot going on there, and that's while they may have some things that we could focus on as a group to pick up on, like the frequencies. What I saw was not in Skinwalker Basin. It was right down the road from me. So, it's interesting, but their data is their data, and we need our own. So whatever we get from them is going to be, filtered in a way, right? Yes. And that's all I got. I'm just going to shut up.
Yeah, true point. So that's also my point, where I say, Brad, what does that have relation to us?
All data is good data. Doesn't matter where it comes from. Just all data.
Yeah. Right. So the idea is now there is. Awesome.
Well, if it was something like with Richard, can you hear me?
Yes.
Kind of breaking up.
Oh yeah.
All right. Well, I mean, if it's like ElectroSense or any of those other background programs, I mean, if it's cheap and you can integrate it into our system and it just records ambient things like the weather or ADS-B data or any of that other stuff, it could be incorporated and it could be useful, then I could say, yeah, sure, let's go for it. I wouldn't hinge a lot on this, though. I mean, it's just we're trying to correlate radio frequencies and gamma rays and everything else with the occurrence of events, and who knows, with enough data we might actually find something useful. But I mean, it's not critical to our system.
No, it's per se not critical. Absolutely, it's certainly a data point. It's the same data point, let's say, as a muon detector or the cosmic watch detector would deliver.
Yeah.
I mean, and you guys have a system that you can add this to. I mean, you guys aren't limited. You can add to what you have to collect and transmit back to whatever. I mean, concentrating on what you're doing right now with the technology that's available is freaking the way to go, in my opinion. And I'm going to build one, whatever you guys figure out in the next couple months, man. I'm on board with this. So, all you engineers, get to engineering is all I got to say.
Right.
We are on it, right on.
Will be cool to put one of our station in a Skinwalker Range.
Oh,
of course we have to do that, yeah.
Yeah, they're boring.
But for that, I've got a suggestion. Think about the episode where they collected the resistinator data from the ground, and they came up with that they could light up a small flashlight with what came from the ground as using it as a battery.
Yeah.
And in I think it was the episode where they had the guests from UAPX, and every time they wanted to record anything, the inverter was shut down. So one solution could be using the ground with let's say 2 antennas. Of producing of using it as a battery for powering up the system.
Yeah.
That would be funny. That would be funny.
Wait a sec. You want to roll out a long wire with 2 ends, plug them in the ground, and
Why
get
not?
a little bit of voltage.
Yes.
To do
I
what?
love it.
To do what?
I love it.
Yeah, using the
Reacting
power
Tesla?
that comes. Yeah, using the power that comes from the ground. If it can light up a small flashlight, they said it was about 300 milliamps, and it's normally using about 5 volts. This is enough for plenty of the equipment we're using right now.
Yeah.
What does it need for the Raspberry Pi 4? It's just to run it, it's 5 volts and about 300 to 500 amps.
Yeah.
So why not try that one? And if they want to shut down the power, they have to shut down their own power.
Okay. Not to be the jerk here, because I've got to go do a photography thing. How would this get us any closer to releasing the alpha build in September?
Good question.
Not at all.
Okay.
So the question is, what does?
Hey
Exactly.
guys, I have one comment.
Yeah.
Has anybody thought about putting a Faraday cage around some of the computers to mitigate any sort of interference?
Yeah, we've got RF material that's shielding that'll do that. Got lots of it.
It's self-adhesive, isn't it? Tommy?
Yeah, it's called magnetic field shielding foil, and it can be just glued to the insides of. No, it is self-gluing. It's a foil.
It's an adhesive. You tear
Yes.
one layer off and then you plug it inside into your.
Yes.
You know.
It doesn't matter. You could use aluminum. You can use copper, whatever. You know,
Whatever,
just create
yeah.
a cage. Yeah, create
Any
a
metal
cage,
that is
drop it around.
deflective.
Yeah.
Copper even better.
You can buy it at Home Depot, Lowe's, wherever, any hardware store.
Yeah. So we have two flies with one clap here. So one side we dampen towards the ambient temperature, and for second we also dampen towards outside RF. So
I do know on some of the military projects they use a copper screen, like a mesh.
Yeah.
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 We use a stainless steel mesh.
Okay.
We using a copper steel, copper foil all the time for covering electronics and stuff like that.
Yeah. And
But I was working on a like a wireless barbecue anyway, and no, this is not funny. And so barbecue. My former boss was barbecue lover, so he spent lots of money. So we was barbecue controller, wireless, Bluetooth, whatever. And so you have barbecue with pallets,
Yeah.
And then I was working with ESP32, the transmitter, and we was putting this transmitter Wi-Fi inside a pallets box, which is all metal. we still had a signal.
Really? How far?
And I don't know how. You know, pallet is like a 2 foot by 2 foot, and you put pallets, and the thing is, so we can measure a level of pallets. So they will inform you if barbecue getting low on a pallet, so you can add it. And so I put this transmitter Wi-Fi inside with a level measuring, like a infrared measuring, and we still get this is Traeger. What is name this barbecue? And we still had good signal inside the metal box, and I was so puzzled.
Because this is aluminum?
No, this is the barbecue is from steel.
So steel, yeah.
Steel.
Then it has
Trigger.
openings, leaking openings.
No, you know, it is like a square box, and in the end you have, you know, for pallets, and in the end you have some kind of spiral, you know, to feeding the barbecue, and everything is metal. Everything is metal, and you close it up, and you still have, you know, like a 20 foot, you still have a signal. And this was puzzling me. I don't know. What can I say?
What was the frequency you were using?
But this is Wi-Fi.
Ah, okay, so 2.4 gigahertz.
Yeah, or 5. ESP32, you know this chip. ESP32, like a Arduino, whatever, and then you have a transmitter and a receiver for Wi-Fi, plus you have Bluetooth. On a boat, Bluetooth and Wi-Fi, I had a signal. This is strange. You know, looking from side of physics, if you put Faraday cage, you have no signal, right?
No, that's not true. It depends on the frequency.
The strength.
If you enter one of those large cargo boxes of the large cargo containers, they are fully made from steel, and you do have a Wi-Fi signal if you are sitting in it.
Really? Wow.
Yeah, it's not completely shut down. It's not completely shielded. I think it has to do with the frequency. If it reaches, let's say, above 1.5, 1.5 gigahertz, because in Germany we had a signal. The telecom was using it before. It was the time when the D1 network started. They were using 1.2 gigahertz for start, and switched to 1.8 because the signal strength was better and no deflections from metal. So maybe 1.5 to 1.6 is the frequency the Faraday cage gets, let's say, buggy or wholly penetratable, so that these kind of signals can get out.
So you think resonate?
Leakage.
How? I mean, from physics side, how? I mean, no mystery there.
The frequency, the wavelengths get very, very small.
Yes.
So if the crystalline structure of metal of any kind gets leakage
between atoms.
Yeah.
Molecules.
Yeah, when you think about it, we currently use our cell phones to go inside of a large department store, which is a metal building.
Yeah.
So it's the same theory.
Yeah, but still they have antennas inside. So they put antennas inside a tunnel so that you can take your phone in the tunnel.
True. But here, no.
Okay.
You go into Home Depot and you'll lose your signal halfway through the store.
Okay, got it.
I can send you my Lindgren plans from the last MRI I built, I'll show you a way not to get any signal out of anything.
Okay.
Their copper enclosures are completely RF proof. Not to make this all about me, guys. I gotta go in like 30 minutes. Do we want to talk about something other than Skinwalker Ranch? Next subject, PTZ. Something that gets us closer to that September release.
Switch over. Go ahead, Brett.
Let's talk about. Yeah. Okay. Go ahead.
No, I just want someone else to talk. I don't have anything to say. I just keeping it going.
I was looking at the Matrix Vision camera, and because we need several cameras, one for the All-Sky Cam and one for the PTZ, that may be the same of the same kind, but we have to consider it. The version that I have here at the moment for testing, the chip's good. Nice image, but it will take us, let's say, to Christmas for a one-man job to build a third-party driver for the Indie server. The built-in, the boxed ones from ZWO, the RZ cams, or the ones from QHY, they are already in the Indie system. And they have cooling capabilities, which is nice for the night sky. So we do not have to use any FLIR equipment. FLIR equipment is just a filter for the near infrared and attached to a camera that is a little bit more sensitive in that frequency. But so we do not need that. I'm not sure if it's a good idea to go for the QHY and the ZWO cameras because the Matrix Vision cameras have the same chips, but need an enclosure to be mountable very easily and need some programming done for the drivers.
Yeah, true. The only reason why I tried to make contact with the manufacturers for this board cameras was only to reduce the costs. But as it now turns out that a bare product, just a board level camera, costs the same as a boxed camera, I definitely say we go with the boxed.
I agree.
Okay. So what's the path of least resistance? Which camera model?
Christian, your proposal.
Okay. We were taking a closer look at the cameras that can be purchased for astronomical use at the moment, and the ones with the IMX 183 chip happen to be the ones that we could mostly use because they have APS-C for the format, have enough pixels up to 26 megapixels. Their pixel size is down to 2.3, I think.
2.4, yeah.
2.4 micrometers. This is good, and the area that's covered is APS-C, so we can use it with a pair gear. And for the other fisheye lenses, let's say the TV lens I was using, I was testing, it's suitable too, because it is a zoom lens. So yeah, the IMX 183 chip is the right one to go.
So that's the chip. Do we have the actual camera model, and can we get that into Fusion? Because I mean, with Boyan and me screwing with the focuser, we got to make sure everything fits.
Yeah.
So it'd be good to start doing that now, as opposed to waiting and finding out later.
Good point.
For that, I think it will take me about 2 or 3 days to get one of those cameras as a ZWO one, and for the QH1 I have to ask. I can do that on Tuesday, so let's say if they are quick as ZWO, it takes about 2 to 3 days. So
If I just
End
know
of
the
next
model
week.
numbers, the exact
Yeah.
model numbers of what we're going to be using,
Okay.
I can look for the various sources because they might be on there already on GrabCAD or
I'll
whatever
get
the
you
hell.
that after our. I'll get you it after at our Discord talk.
Hey,
Yeah, because
Christian.
we're running out of space here on the back end of this thing. That's why I'm concerned.
Hey, Christian.
Yeah.
I have a question. How low temperature on highs affect electronics and optics? What is your experience now?
For CCD and CMOS cameras, if you cool the chip down below minus 12 degrees Celsius, you get an increase of the quantum efficiency up to 94%. Depends on the chip. So from 64 to 94%. And this is incredible because it reduces the exposure time to 1/4 at best.
So this is good. Actually, rising the temperature of the chip, you're rising the noise.
Yeah.
So you have less
The noise, if you cool it down to, let's say, minus 20 degrees, you lower the noise and increase the quantum efficiency.
Wow.
Both.
This is awesome.
Yes.
So,
but also, I'm sorry. By cooling down the chip or whatever, you squeezing squeezing the material.
No, I don't think so.
it squeezes itself when it cools.
Yeah.
Yeah, but I
What do you mean, Bojan, by that?
When you cooling down when you heating up the material, you expand material. When you cooling down, you squeezing.
Yeah.
So my concern is because chip itself, it has silicon whatever, and then gold wires for connection. And then when you cooling down, you can damage.
Yeah.
On a certain time.
I think those chips and cameras are specially designed for it because when I'm looking back to what I was using 20 years ago at the Skinakas Observatory on Crete, they were using cameras that were cooled down to minus 100 degrees with the liquid nitrogen, and they didn't show any differences in sizes. So I think they're already below their temperature threshold.
Okay.
Anyhow, Bojan, this is a product by the company called ZWO, and they sell it in a cooled and in an uncooled version. And the uncooled is already boxed, so nothing to do, just plug and play. And they sell it since many years in the astronomic circles, so it's a product that it's widely used and should not have an issue with temperatures. But one question, Christian, is so the cooled version is much bigger than the uncooled version, of course.
I don't know if they are not using the same enclosure.
As far as I see,
I do not know.
Pretty beefy to me. The cold ZWO that I saw, it had a pretty wide diameter on that thing, which is why I'm concerned and want to get a model of it in Fusion so we could make sure everything works together.
But we are using the diagonal, so it should be out of the way.
Should be, but then we're making changes to the focuser knob and the motor and everything. So that's due diligence. That's all I'm saying.
Hold your horses, guys. We're talking about this camera, either in the cooled or the uncooled version for the Fisheye and for the PTZ, right?
Yeah, we can use any other camera for the PTZ too, but
of course. But the things it's about what we propose.
Yeah,
because these are very high-grade cameras for very low price.
I think the 183 is much smaller than the 1600. And I do not have any problems with the 1600
No.
and the focus mode.
No, Christian, sorry.
So,
I rehearsed my question.
Yeah.
We have same quality on a fisheye and a PTZ. Same quality camera.
Yeah.
But you can also use a normal webcam if you want to. But it's the question what we propose. What makes sense.
Okay.
Yes, of course, it not necessarily makes sense to have a 20K camera on the PT set.
I would say that it makes much more sense to use 26 or let's say 50 megapixel cameras, because the lower the smaller the size of the pixels, and the more pixels you have, the video quality is increased, and you can maybe in the future have some kind of geometry analysis on the material that we can get from the PTZ.
Okay, I want to
So
make
for the
another
PTZ,
point. I want to make another point. I'm looking on the whole station as a concept in questions of what is in and what does it cost. So let's say for the fisheye, we go for anything that is as big as a sensor as possible, right? So
Makes
and the
sense.
fisheye, we need the more pixels, the better, right? Please say yes, everyone.
Yes,
Christian.
without question.
Yeah, I want a Christian to say yes.
Yeah, he's not going to say yes.
He's thinking.
So I think the importance of this IMX 183 is more at the fisheye side than it's on the PTZ side. Just from working as a station, as what it's supposed to be. Of course, you as an astronomer say, I want to have 140 megapixels on my PTZ. Yes, of course. But no one,
you know me.
Yeah, but no one pays $15,000 for such cameras. Yeah? That's the point. So where's the break-even?
I want to.
Where's the sweet spot for the fisheye cam, and where's the sweet spot for the PTZ cam? That's my.
Yeah. Okay. I would say we go for the 183 version for the all-sky cam, because this is the ground material we need. Yeah. Without that, we do not get any objects to point the Pantel Z to. So yes, but if we buy, if we say, okay, we have got the same camera on each side, then you can switch them. Maybe if the camera from the all-sky cam goes down, you just take off the PTZ cam and mount it to it, and won't lose the night, let's say. But for the PTZ, any camera will do. Depends on what you want to what resolution you want to have.
Yeah. So, okay, we have let's say, a lineup of solutions for the PTZ, but there's only one that we can promote for the all-sky cam right now.
Makes total sense.
Okay.
Yeah.
Makes sense to everyone.
And I have written down IMX 183, so that's what we're going with.
Exactly. So, still there's the question about cooled or uncooled. And the difference is size and money, but the money size is $200 difference.
Yeah.
But the quality is much better with the cooled one. So
yeah,
the question is
especially in the night. Within daylight, we won't use the cooling option.
I see.
Because then the exposure time goes below, let's say, 1/4000, and I don't think it's suitable. We do not need the cooling part for the daylight observations, only for the night.
Yeah. But the nighttime is when the fisheye cam, the all-sky cam, really earns its keep.
Yeah.
Because I mean, you're with the PTZ at night with a illuminated object or something that has lights on it, or the strobing thing over Houston that we saw, it's just going to be a more zoomed in, glowing orb. What's important there is that we captured it in the first place, and that we got its behavior, and that all comes into play in the fisheye cam. So there's an argument to be made for a optimally performing fisheye cam at night.
Yeah, but still the difference is $200. So my question is, what do we promote? So the uncooled version
I think.
is. Sorry, Rebecca, go ahead.
Were you gonna say which camera you should promote more? The one that works best at night versus the one that works best in day?
And it's cheaper.
I would say, do you think maybe the camera that works best at night, because that's when UAP seem to be more prevalent around. They seem to be more prevalent and seen around 3-ish in the morning, and I don't know, right after sunset and right before sunrise.
The camera that works best at nights works best at day too, because you can just switch off the cooling. And this is an automatic process, because the camera has got a live feed and looks at the best contrast. And if it sees, the contrast is going down or is going up, then it switches on the cooler. And
So you're
so
$2 more for that, though. What are we up to? Are we up to like $2,000 by doing that?
no, it's $200.
Difference, but
$200.
yeah. Wait, Tommy. So the uncooled version is $550, and the cooled version is $750.
No wars. It increased.
Yeah,
the prices increased up to $700 for the uncooled version and $900 for the cooled version now.
Oh dear.
Wow.
Okay.
In for a penny, in for a pound.
Yeah. That's what I say.
Yeah, that's the problem these days. But okay, if we come back to normal somewhen, then that's the price range it was. So $550 to $750. I hope the world comes back to normal somewhere in the future. So my question is, to every one of you, please tell me, what do you think? What would you, if you invest your money, what would you go for? An uncooled version for $550 or a cooled version for $750? Just give me your opinions.
I would definitely go for the more expensive one because you get better quality data.
Cooled.
Ellie, cooled one? Okay.
Cold.
Okay.
Cooled for sure. Yeah, it's worth the investment. If it's going to give you data for longer and make the equipment last longer, it's worth it.
But also it auto switches, so why not go all the way?
Yeah.
Change, so why not go all the way?
Christian B, you haven't said any word yet. I want to know your opinion.
Hi, can you hear me?
Yes.
That means my microphone is functional. Yeah, I haven't said a word because I'm new here. The other Christian invited me.
This is the other Christian.
Yes.
Heard
you know him
there's
from the videos from the
Good to see you.
balloon start.
You told them here around also about me?
Yes, of course.
Okay, yeah, then I'm the other Christian. I'm a little in the work. I know what's all about. In this case, I'm a scientist. Quality rules. That's the point. I also would say the more expensive one.
Mm-hmm.
We have to go.
Mm-hmm.
Okay, wait. I have a
I gotta go, guys. I'll see you later.
Okay, Brett. See you.
See ya.
Do you watch Skinwalker Ranch, Christian?
Asking me?
Yes.
Yes, I did. I watched every episode.
Okay. Well, Brad just got off. That was a dig at him. So
I understood what you were talking about.
Brad is gone. We can talk openly about Skinwalker.
Yeah, but let's stay on the topic for now, because the thing with the cameras is quite important. And since I was stuck for some weeks with not getting the streaming part ready, I think I figured out where the problem is. We said that we want to use the Raspberry Pi as a video buffer for the Jetson Nano. and this will work fine, but I have to get another WebSocket server running. And this is the problem, that I couldn't get out any video. But the quality of I tried to use my ASI 1600 camera. It's a monochrome one, but it can cool down for about 40 degrees below the ambient temperature. This is quite nice because in summer we need that temperature down there.
What
And
megapixels does she have?
16.
Okay.
It's a 16K camera. It's 3,000. No, it's 4,300.
There is a formula. There is a formula, noise, like a simple resistor, electronic component. The noise rising with temperature. So every electronics component, whatever, generating noise with temperature. Rising the temperature, you rising the noise.
Absolutely.
Yes.
Whatever noise it is, video noise, audio noise, whatever.
If you lower it below minus 12 degrees, even artifacts in the bias frame disappear.
Yeah.
And this is quite nice because the read noise goes down to 1.2 electrons per ADUs, and this is very, very low compared with cameras from the past. So the lowest reading I got from the read noise was 0.53. And this is nothing compared with the other cameras I was using in before. And the images get quite homogeneous. It's they are very, very the noise is less, and the counts. I looked at the counts. They are just with an intensity of 1,200 to 1,600. And if you compare it with the counts,
count per?
That's,
no, it's
count
per pixel.
Count per pixel.
Yeah. The only thing worries me on a focus motor, when a focus motor is steady, make vibration. So these the drivers, new drivers I'm using, these actually, even if you working with like a half a step or fourth step, they have interpolation like a 256 microsteps.
The silent step you're using, they can be switched off, so there is no noise at all when they're not moving.
No noise. So, like I said last week, I was working on this one. It is pretty steady, and this is the thing. It is worrying me a lot. The vibration on a focuser.
I'm using some similar ones with my motofocuser, and I do not detect any vibrations in the image yet. And
on a steady state.
Yes, because they are switched off if they are not operating.
Okay, I working on this right now. Know, and then I was searching last week about software side, software side for the driver, for motor driver, need to be very nicely made.
I think you can use the one that we are already using from BTTS. Because it's they are made from Trinamic, and you can just use them.
Mm-hmm. Also, Trinamic has some kind of the software, so you can tune your driver. So I'm going to.
Yes.
This is actually my focus is right now just to have steady work on a focuser.
Yeah. But you can use the one I gave you from BTTS. it doesn't matter if you use the TMC 2209 or the 8711 or the 53. I don't know. I can't remember. I think it was the 5390. The 5390 can operate NEMA 23, the largest stepper ones. I think 243 too.
What kind of NEMA we have biggest in PTZ?
23.
17.
17.
Yes.
Sure.
17.
We had 23 and 17. So 17 for the azimuth and for the vertical, and 23 for the azimuth.
Yeah, maybe we have to reconsider the 23. I don't think we need that. I'm using my telescope. I'm using. You have seen my telescope. You know how big it is. We do not have to use the 23 for it. For the larger ones, up to 1 meter in diameter, therefore you need much more torque. Yes,
Okay.
but for the smaller ones, no.
Okay.
Up to I think it's 14-inch. We do not need bigger ones.
Okay.
Because you have already got a gearbox made from belts, and so to increase the accuracy, you need that gearbox too. So the torque isn't the problem.
Yeah.
So we can use NEMA 17.
Also, Christian, the set screw. I mean, for the focus for telescope is not that precise. It has some, you know, how can I?
The thread
It has some edges on it, but it doesn't matter because we are in the night sky for focusing. We have a little bit more exposure time, so a little bit more time to refocus. And what we're using is a method that is called full width at half maximum. So the focuser goes defocus it, goes focusing to the defocus and back, and then knows where the position of the focus is in the center. And we're using a Kalman filter to stabilize it.
I forgot on a Serbian is prazan hod, which is you turn but you have no movement. What is name?
Yes, backlash.
Backlash, yeah. So do you think we need to redo? Modify the whole assembly inside, or just leave it on that?
No, we can't. We can go by what is mounted already. It's precise enough for that, because we are not focusing. We have a moving object, and it's moving quite fast because the magnification of the telescope, 37.5 times, is so high that we can't take into account of precise focusing. We're focusing to the best we can, but it does not have to be that precise.
So software with tell us this is the right focus, right?
Yeah, but it slows it down. We have to have a quick focus and not a very precise one. The focusing has to be very, very quick.
But you know what? This motor is not very quick.
Yeah, but the thread does it. So if you have 10 turns for a full and I think it's enough. But if it is not enough, we put a small gearbox in between and get more speed. And maybe it's enough to use full step mode. And for full step mode, that's pretty quick.
Yeah, but in a full step mode, you have more vibration, though.
Yeah, but to get near the focus and then scale it down, that's what I'm doing with BLTS. I have got ramps to it that go up. If you slew the telescope and use the acceleration, it goes up to to full step mode uses the maximum speed that you can get and then slows down, and by slowing down with the ramp the vibrations go down too.
So you want me involved changing the step mode by software?
Yeah.
Yes.
Okay.
So I think going to the
this chip has M0 and M1 input, which is logic table for the. But says on a logic table you can switch the modes, but still interpolation is 256 microsteps.
Yeah, this is the lowest resolution that we can get.
No, what I'm saying, no matter what kind of microstep you're choosing by digital input, you in the end you have interpolation 256 microsteps inside the chip. I was reading data sheet. You know.
I didn't had any problems with scaling.
And also one more thing, because this chip has a serial communication.
SPI, yes.
No, the serial communication. The driver itself has serial communication. UART. It is possible to use only one TINC and 3 chips, because chips has
no.
No. Okay.
No. The no is because it is not real-time capable of handling more than 2 chips at the same time.
Okay.
2 2 can be done. Yes, I tested that with BTTS, but there is a little delay depending on what chip, what motion driver came first. But 3, it's not possible. So focusing and driving in 2 directions, the TINCs are too slow for that, even the biggest ones.
So, Bojan, are you still there? Okay. He immediately left the room. So my question, Kristen, is when we go into AF mode, meaning we do not microstep, but we go very fast from end to end, just to know where we are, and then go into the center, and then go to microstepping and find the sweet spot. Is that the strategy? Okay. Bojan, did
this
you hear
is
that?
the strategy, yes.
Bojan, did you hear that?
Yeah.
Okay, so you go with zero microstepping, without microstepping. You go from end to end.
No. Minimum is half step. Half step.
No, the minimum is 256 steps.
No, the harder.
The highest is full step.
No.
The team C2209 can go from full step to 256.
Guys,
let me share my screen.
Let's cut this here. This goes too deep, and it's only 2 people knowing what you're talking about.
You know, the way.
Can you discuss this with Christian in a private chat or in a DM, because this is boring for everyone else, because this is
okay. I'm sorry. I'm sorry.
No, Bojan, you are not boring. The topic is boring.
Okay, thank you so much.
I love you.
No, you know, the deeper we go to subject, the better outcome will be. And people, but you know, if you want to watch this whatever meeting, you don't expect a show program. You expect people going deeply in a subject, and so everybody can add something. So like a group, like a team, we can do better. Sorry, this is topic like that. This is not topic like I don't know. So you know, we need to go that way.
Yes, you're right. Yes, you're right. But
Sorry.
talking about micro steps, the strategy for doing the AF is more or less given. Everything is very academic. What you're talking now into.
No, it's not academic. This is the problem. We have a problem. In order to resolve the problem, we need to go deeper and deeper and deeper in the details. Sorry.
Yes, true. And Bojan, at a certain time, you have to experiment to find out.
Yeah, I'm gonna do that.
I would suggest you start with the traditional approach. So go very fast from end to end, find the sweet spot, go into the center, switch back to 256 steps, and do the final.
So I'm going to do this.
Okay, we discuss it in private when things are ready. Yeah.
Okay.
Okay, so we agreed to go for the 183 cooled version of the camera. So I'm going to contact my sources so we can get the lowest price.
Perfect. And I would suggest you ask for the uncooled version, because we have to have that one in and test it. And tell me the price so that we can purchase it.
Yeah.
Okay.
Why the uncooled version now?
Did I say uncooled? No, I mean the cooled. Sorry. I mean the cooled one. Sorry.
Okay. Yeah.
Yeah, I mean the cooled one, because even if it's more expensive than the other one, we still need that one, because if we promote it, we should have tested it.
Yes.
Yeah.
Yeah.
So
this is just a chip or a chip with optics?
It's only the camera.
Oh, okay.
Box.
Because the optics, the optics we have around here for, I think it was, when did we buy it? The per gear?
3 months.
Wasn't it last year?
No. 3 months ago.
Oh, okay, 3 months ago. Yeah, maybe, yeah.
So
yeah.
You said you were contacting your contacts at Teleoptics. Do you think there's a chance to get a sample?
Yeah, that's what I'm going to try, of course.
Okay. Just in case. I mean, first ask for a sample before ask for purchase, of course.
Yeah.
Perfect. Yo, I think that's it on my list. I have nothing else to discuss for today. If there are any questions from all of you who are just so nicely listening to, please go ahead and raise your voice.
Christian is so quiet. Christian number 2 is so quiet.
He fell asleep.
Wow.
It's just a picture. He's not moving.
Yeah, just a picture.
So, yeah.
I do have a question.
Questions, go ahead.
A link in your in a DM for this company called C3CLive.com. And basically what they do is they take a fisheye video, or rather video from fisheye, and they make it flat, horizontal.
Oh, rectified, okay.
Right. So I'm wondering if we need that technology for the fisheye.
My opinion, no, because any distortion of the raw material means infringing it.
Okay.
What do you say, Christian?
If we are in need of a field flattener, I would say no. We can do that by software. The field flattener enlarges the focuser distance, and I don't think that we need that. I think we can do it by software.
Okay.
The hardware part is nice, but I would say it's much nicer to use it in real telescopes and not for the old Skycam.
Got it.
Because what is to win? A nice pic for human watch? The software doesn't care about whether it's a fisheye. You have to incorporate those algorithms. If you place something in a fisheye environment via geo coordinates, for example, you have to incorporate the geometry of the fisheye and so forth. But for detection, for even the classification that Lionel does, I don't see a need. It would be a process, an unnecessary process, a load on a process power, which is at the end not really needed. But yes,
And
it gives nice pictures.
And the data below 30 degrees above the horizon, we can't use it anyway because it's too distorted to get anything out of it. Yeah, we can track the path, but and we have to do it because then we know when it reaches 30 degrees, and then the PTZ can take over. Of course, yes, but below that we can't determine any position, and the photometry about it, the how bright the object is, we can't do that below 30 degrees because of the distortions from the atmosphere, the sea.
But we are looking for strange movement.
Yes, and therefore we do not. Therefore, we do not need any corrections below to the horizon. For the movement path, it doesn't matter. And objects are far away down there at the horizon.
But this is the really reason we using fisheye camera to detect unusual movement, right?
Yeah, to get the whole sky incomplete. So yeah, but there are limits. Especially our atmosphere distorts things between 0 and 30 degrees above the horizon. So any optic can't determine the correct position or the correct brightness of an object.
But what it can do is call the PTZ to steer to and have a look. So that's why I would not neglect.
But for the PTZ goes the same thing. So any data collected in between that area is not reliable.
Yeah, true. But an event is
but
an event.
we collected already to have a complete data sample.
Yeah.
So we have to do it, but we do not need any additional software or additional optics to correct what we see on the pair gear.
I'm just thinking it's best, since we have 2 points of data, if the PTZ fails, if the PTZ doesn't zoom in, if the PTZ it's just the point you've got 2 points of data, why not use the second one?
Yeah. Now the question is that we do not neglect the data that is beyond the 30 degrees, what Christian meant. Yeah, astronomically seen, geometrically seen, it goes into the rubbish zone where the seeing makes so much noise that you can't, and yeah, we do not derive anything from there. But what we know is if there's an event below the 30, then it is there somewhere, and we can steer our sensors to.
Yes.
Yes, we cannot decipher the size
capture it, but we can capture it as early as possible, and this is good for the movement path.
True.
This is why we're doing it, but we do not need any sophistication on image quality at that area because it's impossible to do. Maybe we find a way to remove the atmosphere, but I won't suggest it.
I have one more question, Christian. How can we make sure then what we are looking at is physical object, not reflection or something?
Reflections move differently than objects. Reflections at that, depending on where you have them. The most parts of the reflection come from the sun. If there is, let's say, a light in the night, let's say some kind of street light, this is in a fixed position, and you know if it's producing some kind of reflections, then you know in what area these are, and they can be identified and opt out. Yes.
So
The other one can be done by the moon or the sun, and you know their positions and the path of those reflections too. So you can opt them out.
So we can filter out by software.
Yes.
Okay. Any other questions? Ellie, I'm sure you have a question. Hello? Okay. No one there? Gosu? Any final
I don't
questions?
have any questions. No, I don't.
Okay. Thank you. So,
No problem.
Daniel, Snick XX, any questions from your side? Your chance to ask questions if you want to. If you do not want to, I close this session down for today.
When
I
are we
just
going to be able
wanted
to
to.
start
Okay.
the cases? Oh, I'm sorry.
I just
Hello?
wanted to say that the GUI is progressing nicely, and I will be having to leave for work soon. So I just wanted to say it's progressing nicely.
Perfect.
Many things have been done, and I guess I will update on the next meeting.
Perfect. I hope in the next days, certainly this week, this coming week, I will send you all the icons.
Okay, no rush on that. And,
Oh, I will rush. No, I will do it this week.
okay.
Perfect. Thank you. Thank you, Rebecca.
Okay.
Go
Okay, I
to-
have some quick
Daniel,
questions.
go ahead.
Just three separate topics. Just for the GUI of the airplanes on the map on the Fisheye View, that we're using airplanes, and they always overlap in the other software. All of the airplanes are overlapping, and it's very difficult to see anything. So I was thinking maybe we could use some more concise icons than airplanes, like just
Good idea.
a red and a green dot next to each other. Because that, if you actually went outside and looked, then it would reflect the same as in the sky. And you could have a lot more close together.
Good point. What if we make it
Can you
selectable for you? Rebecca?
Can you make icons, Richard, for that?
Yes, I can. What if we make several sizes of icons so that the user can very easily, via the interface, switch between icon size? Daniel, you were talking about the fisheye view or the map view where ADSB data is projected on, right?
That's right, yes.
So Rebecca, I would say we take 3 different sizes, very, very tiny small one, I don't know, 8 pixels, 10 pixels, and then, yeah, two other sizes. So, but I think it's a good idea because it's also something that I always see, and when you use flight aware, I have to zoom and until finally they show up, and when they show up, you have a lot of overlap. So that's a good point, Daniel. Thank you for that. And I think we can overcome this pretty easily.
So can we use some kind of scaling factor?
Scaling what? The icons?
Yes.
Yeah.
Something dynamically?
So I make one size
Maybe.
and the UI lets you decide which percentage of size you are shown?
No, I would say to write a small JavaScript that zooms with maybe transfers the zoom to the icon as well by zooming in with, let's say, the mouse wheel, so that you always have some kind of ratio between the optical field of view and the icon size.
By zooming, you change the view, but the icons are painted on top of that, or are they belonging to the view?
Normally, they belong to the view.
So they would
say
scale with the zoom scale.
Yeah, and if not, we have to write some kind of module or script to do that.
True. Rebecca, you know
I
what he
have
means?
two options. Yeah, I have two options. You know, do the icons for the original view, and then have another option where the person can scroll on the mouse to enlarge in the view and see better. But for example, they open the GUI at whatever size it's preset at, and the icons are small enough so they can see the individual airplanes. And then if they want to zoom in, the entire image will be made bigger so they can see the bigger icons and I guess a close-up of the sky. Is that what you're saying?
Yeah, basically.
So there are actually two ways. Either we place a certain icon with a certain size and then scale it with the normal view zoom. So zooming in means the icon becomes bigger, right?
Yeah, kind of like when you go shopping online, you know, you're shopping for items and you scroll the mouse over a section of that image and then it gets larger. So I think that's what Christian's saying, something like that.
Yeah, but the other way around. In let's say if your field of, let's say 140 degrees and you zoom in to 90 degrees, normally the image of the icon gets enlarged, and if we scale it down so the icon stays at the same size, I think this helps by, if you have two, let's say two parallel planes, then you can separate them much more easily. So downscaling is what I was talking about, with the same ratio that you zoom in.
You click on an icon and then you have data, right?
This can be done too. Yes, this is what Brett earlier mentioned. Was it Brett?
Yeah.
No, Jannik. This is what Jannik mentioned.
Icon, yeah.
So may I summarize? We take 3 levels of icon sizes. So if the user chooses one size of an icon, we place them at the 30% view, zoomed view, which is where all the fisheye is in this circle, the 30% I think it is. And then when the user zooms with either with the mouse wheel or with the plus minus, then automatically, because you zoom the view, all things within will be scaled, also the icons. So in that case, you have to compensate for that.
Yeah, to downscale them.
So zooming in means also downscaling this particular icon.
So that the icon stays the same size in any view.
Yeah.
You know, you need the data from icons. You don't need different sizes, right? You just click on a airplane or a object.
No, the icon is moving along with detected object, and the icon is the thing that you can click on. And
Yes.
the
And
data,
then
if you display all the data all the time, then it covers other parts that may be interesting. So if you have a spotted plane that already has its transponder on, then you do not need any clicking on it. The data is just shown when you're interested in it, and you can do it by clicking or just by hovering the mouse pointer over it.
Hover. But now we need to click because this interface is for touch screens too. So we need to click.
Yeah, and if you point your finger over it, then you have the same as several of.
Not clicking,
yes,
but
then
holding.
it's
okay. Yeah.
Yeah, it's the same as hovering.
Yeah, true. Okay. Yes, Daniel. Is that answered in a way? I think you can do that.
Okay, yeah, that's great.
And you had 2 more questions, did you?
Actually, no, not so much. This was good.
Okay, perfect. So, any other questions? Gosu, you wanted to say something.
Oh, I was just going to ask about the enclosures. I remember seeing something pop up that we were going to be able to purchase one soon.
Yeah. So good point. We're going to open the store with the enclosure on the 13th of June. So in a week. Okay.
Okay. Awesome.
Yeah. So we have to. This week is still for last tests. We had some shipping profile changes, but yeah, I have to say the shipping rates globally went up. So
Oh yeah.
the good
And they
times where you ship such a box for $30 to the US are over. It costs you now between 70 to $100, even more. So
oh man, it's that they even put a fuel surcharge on our
yeah, and
invoices.
fuel came on top of that. Yeah. Okay.
Yeah,
Yeah,
that's unfortunate.
That's unfortunate, but we hope that maybe in the future it will solve its way. But yeah, we can't wait until.
You know what I'm thinking? You know what I'm thinking? Humans progressing so fast, so aliens need something to stop us. This is what I'm thinking.
Yeah, that's a good point.
Good one.
Corona, bullshit like that.
They can shut down our batteries, but they can't stop us.
No, you can't stop.
Okay, guys. With that note, I'd say we round it up for today. I stopped the recording